everybody. Thank you for joining our webinar. This is Garima Takcham. I'm the founder of AkasiaCloud. Today, what we're going to be talking about is comparing costs in the cloud. And we will be going into quite a bit of detail into how we pull up best practices and cost savings options within our products themselves. Let's get started. First, very quickly about our company. We were founded in 2014, and our headquarters are in Santa Clara, California. We also have an engineering team in Pune, India, and we are venture-backed, funded by Thai Launchpad, as well as a number of angel investors. So to give you a quick summary of what our company does, what our products are used for, we're a company that delivers software solutions, and we've built two SaaS solutions that enterprises use to plan for transitions to the cloud. In the last 12 months, we've modeled over 750,000 virtual machines and physical machines for migrations to the cloud. And based on all of that experience, we're able to present to you the best practices around identifying hidden costs as well as hidden savings in the cloud. So the sea of logos there should tell you that we work with some of the largest companies and modeled some production environments for the cloud. The most typical use cases of Akasia are around cloud assessments, pre-migration planning, and identifying optimal savings, as well as creating a business justification for migrations. Next slide. So now let's get into planning for the cloud. So we're able to help with best practices for planning for compute, storage, and network for cloud infrastructure as a service. Now, in many situations, you might want to take advantage of cloud SaaS solutions. We're also able to give you best practices for deploying SaaS solutions in the cloud. For today's webinar, we're going to be focused on the first bullet there, which is around cloud IaaS. You can save significant cloud costs by evaluating for the best infrastructure fit in the cloud for your compute options, as well as for the best licensing fit. So the first one, the infrastructure fit, is important because the bulk of your cloud costs actually come from infrastructure and mainly compute and storage. So if you optimize and fine-tune your infrastructure fit, then you will immediately save a lot of costs right away. The second option for significant savings is picking the best licensing fit. And by licensing fit, what we mean is the usage pattern of your application. So if it's short term, as in it's used just for a few hours a month, then you use a different licensing fit. We would suggest you use the application uptime feature. If you anticipate that it's going to only be used for a few months and then you're going to stop using it, then we recommend that you use the on-demand license. If, on the other hand, you expect that the application will run for a few years, then we recommend you use the reserved instance feature. You'll save a lot more that way. So there are many ways to examine what are the different options for saving in the cloud. So now to drill down a little bit more, let's examine the CPU memory and storage characteristics and map to the closest equivalent. So what we have here are, if you look at the CPU types, or rather the compute types, you have various options. You have general purpose, which is for balanced workloads. Just compute options in the cloud. You have several varieties that you can pick from, depending on the characteristic of your workload. General purpose is for balanced workloads. Compute optimized templates you should pick if your workload is compute intensive. You should pick memory optimized if your workload is memory intensive, and storage optimized for storage intensive workloads. You also will pick the OS type, so Windows or Linux, depending on what is your OS locally. And you can also use options for bring your own license. In particular, Azure as well as AWS offers the BYOL option. And then licensing option, like I said, based on the usage of your application, you should pick on-demand or reserved instance. Even in reserved instance, you have several options. You can do a partial payment upfront or a full payment upfront and get different cost options. You can also pick 1 year or 3 year. And if you have a long-running application which you expect will run for many years, it might be tempting for you to pick 3 year. And if you pick 3 year, you will likely get the cheapest option immediately. However, what we recommend to our clients is to pick the 1 year. And this is because cloud platforms are offering newer and newer and faster templates as they go along. So if you reserve for 1 year, then you have the option of switching over to a faster, newer version at the end of the year. If you pick 3 year, you would not have that option. So that's what we recommend. Now let's get into the actual examples. So we will do two things here. We'll compare cost estimates for a virtual machine, for general purpose, compute optimized, memory optimized, as well as for on-demand and reserved instance. And we'll go into right sizing. I'll describe what is right sizing a little later. And then the next thing we'll do after that is compare cost estimates for a workload. And a workload is typically what you will be moving to the cloud. And a workload consists of the infrastructure plus software. And we will compare the cost for a workload for all these different cloud options: AWS, Azure, Google, IBM Cloud, VMC, and different licensing options and different regions in the same cloud. So let's take a look at the best infrastructure fit for compute. And what's important here is this: you have to examine compute tiers in the cloud. So Google Cloud Platform is the only one that offers custom tiers. The others have standard tiers that you need to pick from. So if you have an odd tier, for example, if your compute is 4 vCPUs and 6 gigs of memory, for general purpose, when we did the mapping, it mapped to 4 vCPUs and 8 gigs of memory. That's because most cloud options offer this as a standard tier. So here you are forced to go with 2 extra gigs of memory, even though you don't need it. In GCP, on the other hand, you can build custom compute shapes, so you will go for a 4-6. In Oracle, because they have very few template options, you're forced to pick 4 vCPUs and 30 gigs of RAM. Similarly, if you are going for another non-traditional option like 4 vCPUs and 9 gigs of memory, then you're forced to go up to 4, 16 in all the cloud platforms with the exception of GCP. So as you can see, your cloud costs for each of these templates varies. It is the lowest for GCP as a rule because of their custom template option. And these are the costs for AWS, Azure, IBM for their general purpose, for 4 gigs and for 4 vCPUs and 8 gigs of memory. So what's important here is that you make sure that you're matching to the right compute tier. Then now, if we take the exact same template and model it for the other compute options, and here what I'm showing you are the outputs for general purpose, compute optimized, and memory optimized. So you can see for the same exact template, your costs change. So for general purpose, AWS is the cheapest at $74.66 a month. But if you pick compute optimized, then AWS is not the cheapest. It's actually just a little bit more expensive than Azure. If you pick memory optimized, then Azure becomes cheapest at $73. This is for the same exact VM. So this is to give you a sense for how your costs vary based on the type of compute you pick in the cloud. And you'll be able to model all of these. These are outputs from our tool, so you'll be able to model all of these in the tool itself. Next, I'm going to show you a little bit of detail on licensing options. So here what we're showing you is on-demand versus reserved instance for two of the clouds. This is for a 4 vCPU, 8 gig memory. And so for on-demand AWS, the cost is $74.66. For reserved instance, it drops down to $32.28. The same VM in Microsoft Azure on-demand is $123.37. For reserved instance, it drops down to $45.25. So these are important things that you again need to watch for in terms of on-demand versus reserved instance. You might note here that there's another cost here, which is for right size. So we're going to talk about that next. Right sizing. Right sizing for compute in the cloud is a surefire way to save. And we highly, highly recommend to our clients that they do right size. And what we mean by right sizing is if you examine this particular virtual machine, the dark blue is what's actually used and the light blue is excess capacity. So for this virtual machine, the on-prem environment had allocated 6 plus 2, 8 vCPUs, 28 plus 4, 32 gigs of memory, and 32 gigs of storage. Now, over the last 1 year that this VM ran, it consistently only used 2 vCPUs and 4 gigs of memory, but used all the allocated storage. So there's excess capacity as far as CPUs and memory goes. So if you were to move this virtual machine fully allocated to AWS, it would be a T3.2x large. But if you right size it, as in you only move 2 vCPUs, 4 gigs of memory, and 32 gigs of storage, then you're dropping down to T3.medium. So your cost relatively will be $351 versus $69. So yeah, okay. So your total cost of storage will be $376 versus $69. So you're saving $307 a month by right sizing for this one virtual machine. And imagine if you're moving thousands of virtual machines, you stand to save a lot of money by right sizing. So this is what we mean by right sizing. The next step I want to walk you through is modeling for an entire workload. You know, it's important, like we talked about in previous slides, to look at your compute and storage and optimize there. But then you're actually migrating the whole workload. And there are opportunities to optimize as you're modeling a workload itself. And in order to do that, let's take a look at the cost variables for a workload in the cloud. They are infrastructure, and infrastructure includes CPU, memory, storage, network, I/O, and the OS version. And then you add additional services. So the additional services you might add would be software licenses, depending on the application you're running on that infrastructure. It could be the supporting licenses such as security, high availability or disaster recovery, load balancers, et cetera, et cetera. And then you will add operational costs such as for administration or for partial or full payments for reserved instances, et cetera. So we will go through all of these to look at what are the ways to optimize for workload in the cloud. Now, just taking a step back, if you look at the technical considerations and business considerations in selecting a cloud, these are the steps we walk our clients through to help them really identify not just the best cloud platform, but also the most optimal savings within that cloud platform. And even though we're a cost modeling company, we recognize that there is much more than costs that goes into selecting a cloud platform. And those would be things like the type of cloud project. You know, it could be a new cloud deployment, or you could be refactoring legacy applications or rehosting, or you could be building out hybrid IT or DR, or it could be a dev test or biz app. So depending on the nature of your workload, we will help you identify the broad category of cloud options. And then we look at the cloud technologies to consider, so IaaS or PaaS or SaaS, etc. So we help you narrow down the pros and cons of all these different platforms within the cloud. And then we review the cloud offerings and capabilities because they're just so vast. Now, these are 3 simple steps, but as we're going through these steps, our products are literally sifting through millions of cloud options and trying to pick the most optimal cloud options for you. In addition to technical considerations, business considerations have a big play. And oftentimes we've noticed that a client will go with a cloud platform simply because they have a long-standing trusting relationship with that company. So it could be that IBM Cloud is a little bit more expensive than the other options, but the customer will just go with IBM because they have a long-standing relationship with IBM. Similarly with Microsoft or AWS, and Google is starting to build relationships with enterprises too, so we're seeing a lot more Google modeling going on. Also with VMware, there could be situations where the customer is not willing to get off of VMware as a platform, but they do want to take advantage of the cloud, in which case they go for VMC. So these are all the different considerations that we go through when we are picking the best option for you. Now, our products come into play in terms of identifying the most optimal options as well as doing all the cost comparisons. We have 2 products. One is for lift and shift migrations, and that's called AIM, or the Acacia Infrastructure Modeler. What it does is it discovers the on-prem environment and models it to the closest equivalent in the cloud. And when it does this modeling, it crunches through a number of things. It looks at the on-prem workload characteristic, and it recommends the right type of compute. It could be a general purpose, a compute intensive, or memory optimized, etc. So all of this is done automatically within our product. It also models for network and I/O because these are items that are supposed to be free on-prem, but in the cloud they become significant cost items. In fact, the whole fear around cloud costs and the fact that cloud costs can surprise you is because of network and I/O. Your network and I/O characteristics change in your application as it's running in the cloud, and you suddenly get a bill that's 3x what you got the previous month. And if you tease that apart, you will find it's things like network and I/O. So in our product, what we do is we carefully examine the network and I/O usage on-prem, and we highlight it when we're doing the cost model so that there are no surprises for you. What AIM does is it gives you a cloud bill of materials and costs, and these form a starting point for your lift and shift migrations. This entire process is iterative, so we examine what's on-prem, then the product comes up with the closest equivalent in terms of compute, then it comes up with right-sizing options, then you add additional resources. You can do what-if analysis, such as swapping out on demand for reserved instance and seeing what happens, or swapping out different regions, etc. So it's an iterative process to arrive at the most suited cloud option for you. That is AIM. That is our first product. Our second product is ACM, and ACM is a product that people use to plan for new cloud deployments. And this could be things like where you want to take advantage of cloud-native resources such as serverless computing or in-memory database or NoSQL or deep analytics, machine learning, etc. in the cloud. So the cloud has a lot of very innovative solutions being offered, and you can use ACM to model for all of those solutions. And then finally, we also have services. So while our products are extremely intuitive and easy to use, our engineers and consultants have built a great deal of knowledge of cloud platforms, resources, as well as best practices. So a lot of our clients rely on us to do the entire assessment, or they rely on us to be there to just answer questions for them. So we'll go into a little bit about AIM, how it works. So you would first discover the on-prem environment, and when we go through a demo, I'll show you how that's done. Then we do the right sizing and what if analysis. And this is where you vary different options. And then finally, we model cloud costs in minutes. So you get the entire modeling done in just 30 minutes or less. This is how ACM works. With ACM, there's no discovery of the on-prem environment. Instead, you just click what you want in the cloud and model it. Here's the another diagram of how the product works. This is our product, and we do the ingestion of the on-prem environment. We then map it to all the cloud resources, and these are resources that we pull into our tool on a daily basis. And once the mapping is done, we present you with the in-cloud OpEx and the bill of materials. These are more steps, and we'll be going into these steps in detail a little bit. So first is the on-prem discovery, then here's the mapping, then the modeling and the cloud bill of materials. We are also building a solution to help you optimize your environment once you've moved to the cloud as well. So a quick view into the on-prem discovery. We have two types of discovery. One is quick discovery and the other is deep discovery. Quick discovery is where we simply pull data off of existing monitoring solutions. Most enterprises have monitoring solutions that have already been deployed, and a lot of enterprises are extremely sensitive to more probes being added to their environment. So for those enterprises, what we do is we simply pull data from their existing monitoring solutions. So we're able to work with VMware, RV Tools, Hyper-V, as well as all your standard management tools. And we can also take third-party input using our published CSV format. In situations where perhaps the customer's environment is very old and they don't have monitoring solutions, what we do is deep discovery. So deep discovery takes days and weeks, and it's a little bit more involved. And at the end of deep discovery, we're able to see a service graph that includes the application, infrastructure, the dependencies between the applications as well. The type of data we require is mainly around the infrastructure, so the make model of the host itself, the VM data, and the utilization history. We make sure to not collect any confidential information, and the output of our collector are human-readable CSV files, and so this way you can make sure that whatever data is being uploaded into our SaaS solution does not contain any confidential information. So a little bit on our discovery solution. Like I mentioned earlier, we have quick discovery and deep discovery. So quick discovery takes in the order of minutes. And here we can pull data off of existing monitoring tools, like I said. And we can also take input for physical assets. Deep discovery is where we go in and instead of leveraging off of other monitoring solutions, we are doing the monitoring ourselves. And this can take hours or days, like I mentioned. And we can also leverage other third-party or open source monitoring tools such as Nagios, Ganglia, etc. This is a little bit more detail. In terms of supported third-party discovery tools, we're able to use BMC, Puppet, Nagios, AWS's discovery service, as well as ServiceNow. And if you have any other third-party tools, we're able to build a collector off of it very quickly. Here we go. So now, once we've done the discovery, the next step, what the product does is to map to cloud resources. And this is where we do the as-is mapping as well as right-sizing. And our right-sizing algorithm is extremely sophisticated. So we take a look at not just the usage across the past whatever period of time we've done the monitoring, but we're able to calculate for different usage types, such as 95th percentile or average or mode. We calculate the CPU benchmark factors whenever needed. And we then determine the best fit, but we include a 2.5% tolerance. This is just to give you a little bit of headroom so that your application doesn't hit up against the higher end. Then we determine the type of storage required as well as the capacity. We match the guest OS. Then we look at the region and review availability. And we remap if needed because different regions have different tiers of compute as well as different costs. So what we do is we model for several options and come up with the best option. And then we present the final instance and the cost for on-demand as well as reserved instance. Then we model for savings in the cloud. And right-sizing is one that we already talked about, but these are the other opportunities for savings. And I'm going to go through them with a slide each with a customer story so that you know how it could apply to you. Here's right-sizing. We already talked about it. It is essentially the difference between what's been allocated versus what's actually being used. And you can save a lot by migrating only the portion that's being used to the cloud. Application uptime is another one. And here is an example. This is an actual customer output where they had an analytics application that ran only 20% of the time on-prem. And so they said instead of reserving a whole bunch of infrastructure on-prem, how about we move this to AWS? And in AWS, they took advantage of the pause and resume feature, where you can pause an application and you don't pay for the period of time it's paused, and you can resume it when it's ready to run, and then you start paying for it. So using that feature, they found that the application would cost only $4,000 a month in AWS instead of the $41,000 that they were paying for it on-prem. So they saved a good 90+% on this application by moving it to the cloud. This is one very cool way of saving using application uptime. The next opportunity to save is elastic infrastructure. And the beauty of the cloud is that anytime you need additional resources, they're available to you. So a lot of our clients model for elastic infrastructure. And so this is one example where we looked at the application characteristics and we modeled for various options, as is, right size for mode, right size for 95th percentile, and right size for peak. So we modeled for peak. This was the 95th percentile, and this was mode. As is was something beyond this. And so here the customer's intent was that the peak variables here were fewer and far in between. So what they said is they wanted to either deploy mode or 95th percentile in the cloud, and anytime they were expecting a peak, they wanted to be able to add additional VMs to this application and manage it that way. So by modeling for elastic infrastructure, we showed that this customer could save over $10,000 a month. And they modeled for Azure and IBM. At a later stage, they did also include AWS into the modeling and VMC, and we'll take a look at that as well. BYOL is another option. This is where you can reuse your on-prem licenses in the cloud. Azure allows you to carry over Windows licensing, and AWS followed suit, so they also allow you to carry over your Windows licensing. So you save quite a bit there by not having to purchase OS licenses in the cloud. And in this example, the difference in price for OS included versus bringing your own license was $62,000 roughly versus $53,000. So the customer saved 14% by reusing their licenses. There are some rules around BYOL that you need to be cognizant of. So you can use BYOL for infrastructure that does not vary very much. If it does vary a lot, then you're better off using the licenses that are included in your template within the cloud. So there's less management that way if you use your cloud licenses. Some rules to be cognizant of. Another option for saving is by going for VMware in the cloud. And this is an actual modeling that a partner did, and they shared it with us. We thought it was extremely insightful. So this was an environment that had 1443 virtual machines, and the client wanted to compare this for EC2 versus VMC for a 3-year reserved instance period. And these were the options. So not only were there savings just for infrastructure, there were savings for monthly administration because the client could simply use their existing VMware admins instead of going off and either hiring new AWS admins or retraining their current admins to be able to now manage their EC2 instances. So these were the savings in their monthly recurring costs. The other area they saved a great deal was in their one-time migration. And this is because if you are refactoring from an on-prem VMware to EC2, there's quite a bit of rewriting of applications, et cetera, that goes on. So your one-time migration costs are quite expensive. Versus if you're doing a lift and shift of your VMware environment, then your changes that you need to make to the infrastructure are minimal. And so your migration costs were a lot lower. In this instance, the difference was quite a bit, from $289,000 to $22,000. So this is another great option for saving if you have an on-prem VMware environment. These are our features and how we compare across all the different clouds. So we support the public cloud options, but we also support VMware on AWS and VMware on IBM Cloud. The difference between these options is that VMware on AWS and VMware on IBM Cloud, we model for the bare metal infrastructure that supports the VMware environment. So we have to do the discovery for all of these environments. We do the mapping for all of them. We do the right sizing for all of them. But then we have additional features such as bin packing for bare metal for VMware hosts, and this comes into play for VMware and AWS, and bin packing for multiple configurations of bare metal servers, and this comes into play when we're modeling for VMware and IBM Cloud. And we model for hidden costs across all of these. And finally, what you get is the cloud bill of materials, and this includes the cost comparisons as well as the actual part numbers. So these are the actual part numbers that you can then input into any provisioning tool, and you can start to deploy your cloud environment. Overall, the benefits of using our products is that it's much, much faster, so in the order of a few days versus months. It's also far more accurate because algorithmically we are parsing through millions of cloud resources and options to come up with the closest equivalent, which is difficult to do manually. And you're also able to compare multiple clouds very quickly. So these are some of the benefits of using our products. We have a new feature called Sales Insights. And this is for customers who are our customers who are consultants, as well as for managers who are looking across multiple departments. So you can look at the systems that have been modeled across multiple departments as well. So with that, these are some more details. So what I'm going to do is go into the product itself and show you the features of the products here. So here we go. Let's go to the beginning. So you would access our products by going to sas.akasiacloud.com. Here are our two products, AIM and ACM, and I'm going to quickly show you the features of AIM. The first thing you would do with AIM is discover the on-prem environment. And here I already have 5 environments that I've discovered. These are, the host and VM counts. But if you had a new environment to discover, you would download our remote collector and then ingest the environment. So you could use our collector here for VMware, or you could use the output from RV Tools. For non-VMware datasets such as Hyper-V, OpenStack, Physical, we also offer collectors, and you can use our collectors, or you can download our template file and input the data manually. If you would like, you can also take advantage of our consultants who can do all of this for you. So once the environment has been discovered and uploaded, it shows up as one of these. Then we go in and look at the details. So here what you're seeing is the infrastructure that's been discovered. 108 hosts, so many CPU memory, disks, etc. It's supporting 1675 virtual machines, of which so many are on, so many are off. Here's your network and I/O, and this is important because, like I mentioned earlier, these become significant cost items in the cloud. And so you really need to be able to model for these as well, which we do. Right here, you can swap out all the different regions. Within our product, we have the price books for all of the regions, and so you can simply swap them out. Here's your on-prem costing, and these are items you can edit also to make them more custom to your environment. Now, this is just a bird's eye view of what we've discovered. Likely right after this is where you create your modeling groups. And to do that, we go here. What our product does is, based on the discovery, it pre-populates the modeling groups that are likely to be used. And you then have the freedom to go off and create your own modeling group, and you can build it from scratch, or you can pick one of the pre-populated modeling groups and model that. So once this comes up, I'm going to show you. So you can look at groups that have been pre-populated, such as host, OS, subnet, applications, etc. So we'll take a look at hosts. And so these are all the hosts that have been discovered and laid out. You could pick any of these and add as a new group. This is typically what people do when they're end-of-lifing certain physical servers, and they want to model all the VMs on those physical servers for the cloud. Another option is OS. So all the OS versions we've discovered, we lay them out here. So this is another way to pick an OS version that you're end-of-lifing and say, let's model this for the cloud. Subnets. Subnets are a very cool way of modeling applications that should be moved together. Applications that talk to one another and are interdependent on one another are usually placed on a subnet. So this is a very easy shortcut within our product where you can simply pick a subnet and all the applications that talk to one another on that subnet will go together. Then we have tags. In this instance, we use tags to read the applications running there. So we have SharePoint, Analytics, Cascade, Apps, etc., etc. So you could pick any of these as a new group, and what that would do is pick up all the VMs supporting this application, and that would become your move group. Another cool feature there. Applications, I already talked about. Data centers. So here, there were 2 data centers being managed through this vCenter, and if you're if you're shutting down a particular data center, you can just pick all the VMs on there and model it. Clusters and powered state are the other options. What I'm going to do for this example is I'm going to pick this one here. It has 435 virtual machines. So I'll say add this as a new group. So we've picked that, and I'll say proceed to cloud modeling. and I'll say all of these, add them to my modeling group. And then now I'll say compare cloud estimates. And this is where what the product is doing is examining each one of those 435 virtual machines and mapping it to the closest equivalent in the cloud. And what we're doing at this point is doing the mapping of general purpose versus compute optimized versus memory optimized, etc. So we take care of all of that for you. So for my 435 virtual machines, here are my pricing options. So these are for right-sized variables for AWS On-Demand versus Reserved Instance, VMC, Azure, IBM. I could compare costs here for as is, where my prices change dramatically. So just for AWS On-Demand, it's $210,000 versus right-sized, where it was only $76,000 for On-Demand. You can look at different things like compute costs, storage costs, network, I/O, etc. So what we're going to do is examine the right-sized costs. As you go lower down, you get to see cards for each of the different options we were showing in the charts earlier. And what I'm going to do here is pick a cloud. So I'm just going to go ahead and pick maybe AWS Reserved Instance. And here what we're going to see is now the product is building the bill of materials. So you'll see the actual AWS part numbers. So here we go. So the mapping of each of these VMs to templates within AWS. So we picked C5 large because this appeared to be compute intensive. We picked M5 here because this was memory intensive. This appeared to be general purpose, so we picked A1. And the other interesting thing to note here is that we give you two lists. This is for as is, and this is for right size. And here are your right size savings. So if you're curious about how we came up with these savings, you can look at the configuration tab. And here is where we show you the as is versus utilized. So several table columns here. So in the dark lettering here is what's been allocated. And the light blue here is what's actually being used as in right size. So if you look at something where there's a lot of savings, let's take a look at this particular virtual machine. 24 vCPUs allocated, 175 gigs of storage, 192 gigs of memory. However, very little of it was actually being used. Out of the 24 vCPUs, only 2 were being used. Out of the 175 gigs of storage, only 106 were being used. And out of the 192 gigs of memory, only 4 were being used. So there's quite a bit of savings from right sizing here, which the product calculated in seconds. And you can go back and look at these, and you can see that there's a big difference here in terms of what we're recommending. What you can also do is override our recommendations. So you may have information that may cause you to override these, so you can double-click on this. And the entire list of compute elements is available here, so you could pick anything else, and that will automatically be included. So this is where our product has done the right sizing, and we're building a bill of materials. And the next thing will be to add additional cloud services. And this, again, is where the entire price book is available here. So you could pick additional VMs or storage. So we offer all the fields as you need to fill them out for the cloud options. You could pick security and identity. So for fun, I'm going to add a firewall. I say it needs 4 firewall nodes. Okay, 4 rules and 100 requests coming through the firewall. I'll say add product. There we go. the next thing I'm going to do is maybe add analytics BigQuery. So once again, I have the helpful form coming up here asking you to tell it what it needs. I'm going to add product. So I've added additional resources. You can go back and add anything else you need. It could be HA or any management tools, or maybe you need databases, traditional databases added. So you could add any of those. For this example, I'm going to move on and say add other costs. Now here, it's going to prompt you to say add your one-time costs and your monthly recurring other costs. So I'm going to say and I'm going to leave this alone for now. And I'll say proceed to cloud report. And this is where you get the final report. Okay, so here we go. This is the final report. You have your on-prem VMs. These are the 435 that we modeled. These are the costs. These are the AWS costs for various different options, helpfully laid out for you. And here is the full bill of materials. Go through it quickly. And then I'm going to save this. You can export this as a PDF or a spreadsheet. You can also save it and come back and edit it further. I'm going to say AWS. This is the one that we modeled together, and I'm going to save it. And then I'll show you how you can compare the workload. So we just modeled this workload for AWS reserved instance. And I have modeled the same workload for other cloud options, and I've saved them here. So I can compare them to each other. So let's see what we can do. Since we just did reserved instance, we can look at AWS reserved instance and Azure reserved instance, and we can compare those costs. I'll say show reports. Here we go. So we're looking at the same exact workload, but for AWS reserved instance and Azure reserved instance. And here what we're looking at are the on-prem costs, which are the same for both cloud options. Then we're looking at right-sized costs. And the difference here is for AWS reserved instance, it's 53,633. And in Azure, it's 20,182. If you move it as is, it is 13,864 in AWS versus 62,486 in Azure. So these are the comparisons for the same workload in AWS versus Azure for the same region. It's US East. And then as you scroll lower, you get to see the same data in tabular form, and then a breakdown of your costs as well in terms of network, I/O, compute, storage, etc. Okay. So this is one example. I'm going to show you another example where we're comparing multiple clouds for on-demand. So we'll just go in here. Here. And we go into Insights, Cloud Insights. So now what I'm going to do is compare a number of different clouds for on-demand. So IBM Cloud is one, GCP is the other one, Azure, and AWS. And this is for the same exact workload. I've modeled them previously. Let's say show reports. Okay. So now for the same exact workloads, we're looking at the costs for IBM Cloud, GCP, Azure, and AWS. So you can see the relative costs. You can see GCP appears to be the lowest for right size. And if you weren't right sizing, also GCP is the lowest. Between Azure and AWS for on-demand, Azure is more expensive. Interestingly, if you looked at reserved instance, this was for reserved instance, Azure was a lot cheaper. This should tell you that if you're going for reserved instance, Azure is the cheaper option, but if you're going for on-demand, AWS is the cheaper option. And IBM Cloud is cheaper than all of these. So if you had a preference for IBM, this would add to that preference because it's showing to be cheaper than the others. Here's the same information in tabular form. And then we have the individual cards of the cloud platforms shown here. So this is our product, and as you can see, it's extremely intuitive and easy to use, and we make sure to address all the questions that come up during a migration planning process in terms of the most optimal resources to choose, how do you compare, how the cloud costs compare, and within a particular cloud option, how do other resources compare. So with that, I'm going to see if there are any questions here. Feel free to type in questions, and I'll be taking them right now. So let's see. Do you take into account the different types of storage, SSD, HDD, IOPS, etc.? Yes, we do. So when we do the on-prem discovery, we do examine the storage. You should know that when we are picking the options for storage in the cloud, they end up being different simply because the cloud has modern storage. So, for example, you can pick your storage option here, and I'm just going to open a new instance, and I'll show you that feature. So here we're looking at storage. So we're entering the storage type, and we're picking, the amount of storage, and we're picking whether it's general purpose or standard. So yes, we do help you model for general purpose or standard. There we go. So these are the costs for the SSD that we picked. What is the comparison cost for pulling data out of one of the cloud providers? Yes, we also take care of that. So if you have an environment running in AWS and you want to figure out what are the costs for Azure, we are able to discover the AWS environment and then carry on with the same mapping and modeling we would do for the target data set for Azure. So yes, we are able to do that as well. Okay, so it appears that that is all the questions there are at this point. We do have a few more minutes, so feel free to enter any questions if you need to. We are recording the session, and we will send out the slides as well as the recording of the session to all of the attendees. So thank you so much, and this is the last call for questions. Let's see. All right. With that, I'm going to conclude this webinar. Thank you so much for joining us, and I hope you have a good rest of the day.